Greetings, guys. We are starting week 10. This is called the double angle identities. You will find that you are now in, section 5.5. This brown box can be found on page 225. And here's the thing. I need to do a little intro here. Very important information for you going forward, because we have to do a lot of computational trig based on this information. But I need you to understand that these formulas here are actually formulas you could generate yourself very easily. And why I want to mention that is sometimes in trigonometry, you forget a formula or you're drawing a blank on something, but they all come from something you already know. I've been trying to plant that seed as we go. So let me just, I'm going to go through these double angle identities. And also in your book, this is not written in the brown box. This one right here. But I want you to see that all the skills you have acquired up to this point allow you to generate every single formula here. And that's a good skill. And you might wonder, why do we do identities? What are they good for? Well, you're going to see identities come into play when I show you how to do this one right here, okay? So, let's begin. If I wanted to, I could say the sine of 2a equals 2 sine A cosine A. I am just copying down exactly what it says in the brown box. But why is that true? Well, let's examine that. So here we go. Sine 2A is called a double angle formula. What it means is you're taking the sine of A plus another A. Usually we have A plus B. No, we're going to say, what if they were the exact same angle? And you might say to yourself, why would I want to do this? Well, that's going to come up in the other lessons. But what does it mean? It means I'm going to do sin cos cosine. There's sine of A, cosine A, plus cosine A, sine A. Now remember, the order in which you multiply two things does not matter. I could say cosine A times sine A is the same thing as sine A cosine A. So what does that really give me? It gives me one of them here. It gives me one of them here. Guess what? I have two of these grand total. So there's the formula they want you to know. They want you to know this is equal to that. And all I did is I used the sum formula for sine. Now cosine, I'm going to scroll up here. Cosine has three different versions of it. And it all depends on what information they provide us in the problem, which one of those is the best one to use. Sometimes it's one is quicker than the other, but how did they get those? I'm going to do this real brief, but you're going to see that all you really need to know is if they give me something like cosine 2a. They're really saying you have the cosine of A plus itself, the same angle twice, and then you go, oh, this is couscous. So I'd say cosine A times cosine, not B, but A again. In a sum formula for cosine, it's a minus, and then we'd say sine A, and then you go, oh, well, cosine A times itself is called cosine squared A, minus sine A times itself, whoa, what the heck happened there, is sine squared A, and that is the formula they gave you. It's right here. It's the very top left formula. But how did they get the other ones? Well, it's based on something you already know. So always rely on the fact that in trig, you have many different ways to visualize something. If I take, not the number 8. If I take cosine squared A plus sine squared A, what does that equal? Well, that equals 1. We already know that. So if I wanted to, I could, let's say, move this guy over to the other side. And you might go, okay. Then I'd cancel those, and I would say, you know what? What this tells me is that cosine squared of A could be written as 1 minus sine squared A, and then I could substitute in for this piece right here. I meant to go back to I could substitute in right here. I could say, hey, cosine squared A, you're the same thing as 1 minus sine squared A. Don't forget, they had this piece. That's a minus sine squared A. Hey, that means I have 1 minus 2 of these exact same guys. And this dude right here happens to be another version of that formula. Look at the top right-hand one in the brown box. So let's see here what this tangent double angle thing is all about. Because a tangent to A just means I'm going to say that's the tangent of A plus another A. What does it equal? Well, in the formula for sum, I would say it's tangent A plus tangent B. But I don't have a B, I have another A. And in the bottom of that formula, it says 1 minus tangent A times tangent B. But I don't have a tangent B, I have another tangent A. So if you look at the formula in the brown box, it's written like this. 2 tangent of A, over 1 minus tangent squared A. That guy is called tangent to A. Now, this is not in the brown box, and this is the point of this whole intro lesson. I have to get you guys to see that sometimes they don't write out every single version of a formula because you can find it yourself. So this right here, this statement, what does it look like? It looks like an identity. So I am going to show you that 2 tangent A minus 1 over 1 minus tangent squared A is the same thing as this, which is not in your brown box. I'm telling you, it's a valid move, but how did they get there? Well, I'm going to do a left-hand identity. I'm going to do a left-hander right here for you. And I am going to say that 2 tangent A just means 2 times sine A over cosine A, divided by 1 minus, well, it would be a sine squared A over cosine squared A. Now, we had an identities test, and we had a piece of one of the puzzles that looked like this. And some people did this the hard way. When you see a double fraction, and you're going to see them in your future, remember, take the entire top and bottom and multiply by the LCM. The LCM is whatever's in the denominator that is the coolest. And that would be cosine squared A is the coolest. Cosine squared A is always cooler than cosine A. Now, another thing, since I'm taking this as an opportunity, if you don't put this in parentheses in the top and the bottom, you are being extremely impolite. Because this statement right here is the correct statement. If I take away these parentheses and these right here, I am telling you that this is the only part right here. Whoops, oh, I forgot I'm using the eraser. This is the only part right here that's getting multiplied by this. That's not what I said. That is not right at all. So let me undo that. This whole chunk is getting multiplied. Will Miss Quigley take points off for you for doing that? Yes. Did I take points off for you for doing that? Yes. Parentheses are a part of our written math language. So, here we go. I'm going to take this and I'm going to multiply it here. And if I do that, one of these is going to knock out one of those. And I'm going to end up with 2 sine A cosine A on the top of my fraction. If I distribute this, what's going to happen? I will get a cosine squared A minus, and they'll cancel here, a sine squared A. Now, just look at that for a second, because that is the brown box. What was in the brown box? Well, this thing on the top here is called what? It's called sine 2A. It's the double angle form for sine. This guy is one of the 3 versions of this, cosine 2A. So what did I do? I proved that the left-hand side does equal the right-hand side, and away we go. That is a valid form that we can use when we are trying to compute stuff using a double angle formula. Now, I mention that because in your future, you're going to be doing a lot of stuff where they ask you to calculate things based on this. So, just to kind of give you a little glimpse into your future, and this is not I'm not doing a lot of stuff here just to get you ready for the next lesson, but let's suppose they gave me something like this. Here's an example of the type of thing you might see. They might say something like this: cosine squared 15 degrees minus sine squared 15 degrees. What does that equal? And I say to myself, well, heck, I don't have any cool special 15-degree right triangle trick that I know, but you'll notice this is given in the format of cosine 2A. So I can back this out and say, well, this is the same thing as cosine 2A, but what angle are they actually using for A? They're using a 15-degree angle. So this statement, what does it actually become? It's the same as saying cosine of 30 degrees. And then I go, oh, well, cosine of 30 degrees, I don't even have to draw a reference triangle. I'm doing it so fast and sloppy because I know right away my answer's rad 3 over 2. My answer's rad 3 over 2. Bam. What is the cosine squared 15 degrees minus sine squared 15 degrees? That's what it is. You're going to see some computational stuff, and of course, what do we want? We always want exact values. That means no decimals. It's either fractions, rads, or sometimes it's a 1 or a 0 or a -1. That's what we're after. So, double angle formulas. We're going to go into those a little bit more. We definitely will. But this overview, I also want to remind you of some stuff. Not everything's a double angle. Sometimes it's 2 angles or whatever. So here's what I wanted to kind of say to you. If I had secant A plus B, you go, wait a minute, there's no secant formula. No, there isn't. They didn't write that. But that would just be the same thing as if I put 1 on the top and cosine A plus B on the bottom. That's not written in a brown box in our book, but it's true. It is totally true. So if I said, what is, let's say, cosecant of A plus B, you could say, oh, well, that's the same thing as 1 over sine of A plus B. Oh, do you think it works for cotangent? Sure it does, but cotangent, all of this stuff works that way. So I just showed you this guy. Let's just back up a step. I just showed you this guy is the same thing as this. Well, what if they pull this one on me and they say cotangent 2A? Well, it's just the reciprocal, so I could rewrite it as this. This is all information based on what you already know. So the formulas in these brown boxes, what I'm trying to hint at is they don't always provide you with every variation that there possibly is. There's lots of variations they can give you, but you can deduce them based on what you already know.